In computer architecture and operating systems, the concept of kernel space and user space refers to the division of memory and privileges between the core operating system and user applications. This separation is crucial for system stability, security, and efficiency. Kernel space. Kernel space is the privileged part of an operating system's memory that is reserved for the core operating system itself. It contains the operating system's kernel, which is the heart of the system responsible for managing hardware resources, providing services to user programs, and maintaining overall system integrity. Key characteristics of kernel space include high privileges. The code running in kernel space has the highest level of privileges and can access and control hardware resources directly. This includes managing CPU scheduling, memory allocation, device drivers, and I/O operations. Protected. Kernel space is protected from direct access and interference by user space applications. This isolation ensures that critical system functions are not compromised by erroneous or malicious user code. Stability. Kernel code is typically rigorously tested and highly stable. Any errors or crashes in the kernel can lead to system-wide failures, so stability is of utmost importance. User space. User space is the part of a computer's memory where user applications and processes run. This is where all the software and programs you interact with, such as web browsers, word processors, games, and other applications, execute. Key characteristics of user space include lower privileges. User space programs run with lower privileges than kernel code. They do not have direct access to hardware resources and must request services from the kernel via system calls. Isolation. User space applications are isolated from each other and from the kernel. This isolation prevents one application from affecting or compromising the stability of other applications or the core operating system. Flexibility. User space applications are more flexible and can be developed and modified by users and software developers without risking the stability of the entire system. Communication between spaces. For user space applications to access hardware resources or perform tasks that require higher privileges, they must request services from the kernel. This is done through system calls, which act as gateways between user space and kernel space. System calls allow user programs to request operations like reading from a file, creating a network connection, or allocating memory. Advantages of the division. The division between kernel space and user space offers several advantages. Security. It enhances system security by isolating user applications from critical system functions. Malicious code in user space cannot directly compromise the kernel. Stability. It ensures the stability of the core operating system. Even if a user program crashes, the kernel remains intact. Resource management. It allows the kernel to manage hardware resources efficiently, preventing conflicts and resource contention. In conclusion, the division between kernel space and user space is a fundamental concept in computer architecture and operating systems. It ensures the stability, security, and efficiency of modern computing systems by segregating critical system functions from user applications and providing controlled access to hardware resources through system calls. This separation is essential for maintaining the reliability and security of computer systems.